borrow a book. Do you write in your book? Oh, you do. Won't borrow yours then. Bella, I'll just borrow your book. You don't write inside the book, do you? No. Right, just take some examples. So, what we're going to have a look at now is exponential equations. There isn't any new formulas. We're just going to use the formulas to solve problems involving the exponent here. So, let's have a look at some examples. Let me do, for example, something like this. No, that's too easy. Something like this. Wow. That's weird. Yeah, okay. Cool. All right. Okay, so the trick with this type of problem is you need to change the 81 or the 9 so that they're both the same number. The 81 should be changed to what? 9 squared is 81. Yeah. And that's 3x minus 3. 9, 3x minus 3. So what happens here? Yeah. 6x minus 6, and here, nothing, it's the same, isn't it? Now, 9 to a power equals 9 to a power. So the powers, yeah, they must be the same power, right? It must be that 6x minus 6 equals 3x minus 3. Which means that 3x equals 3. So finally, x must be 1. Okay? Can you write that example down? That's our first example. You got that? Yes? Can I scroll down? Let me give you one to try, make sure you got it. Here's one that's not so difficult. Well, I don't think it's too bad. 64 power x plus 2 equals 4 cubed. Try that. No, I don't think it's 1. Minus 1, is it? 64 is 4 power 4, is it? No, 3. So that means 4 power 3x plus 6 equals 4 power 3. 3x plus 6 equals 3. 3x equals minus 3, so x equals minus 1. Okay, good job. Let's have a look at another example. Okay. Do you know, I think you could try it before I do it. I think you might be able to get it, maybe. Maybe. 2 power 9x plus 9 equals square root 64 power minus 5x minus 5. Give that a try, and then I'll give you the answer. I think you could do it. Okay? Think you got it?
Yeah.
2 power 9x plus 9 equals 64 power minus 5x minus 5 power a half. But you can change 64 into 8 squared. 8 squared power minus 5x minus 5 power a half. Now what happens to all those powers? They multiply, don't they? So you get 8 power 2 times minus 5x minus 5 times a half. And the half and the 2 cancel. Whew, okay. So this is 2 power 9x plus 9. And 8 is 2 power 3 power minus 5x minus 5. So that's 2 power 9x plus 9 equals 2 power minus 15x minus 15. So that's 9x plus 9 equals minus 15x minus 15. 24x equals minus 24. X equals minus 1. Oh, there's more than one path to the answer, yeah. Did you get minus 1?
Yeah.
Good job. Okay. You could square both sides. Yep, that'd work too. Yeah, maybe that'd work. Okay. Do you need to write that down, Maron? Yeah, you need to write that down? No? Did you? You got it? So I can continue? Okay. Alright. Example. 4 power x minus 6 times 2 power x plus 8 equals 0. Now, does anyone know what to do here? Nice try. So what I'll do, I'll change the 4 to 2 squared. Okay? And then what I'll do is a swap. I'll change this to 2 power x squared. Now, can anybody see what type of equation I have? Quadratic. Because look, it's a thing squared minus 6 times the thing plus 8. It's a quadratic. You know, you have something squared minus 6 times the something plus the 8. It's a quadratic. Except the variable isn't x. What's the variable? 2 power x.
Yeah.
So if I factorize it, it will be like this. minus 2 minus 4? Yeah, okay. So I get 2 power x equals 2, or 2 power x equals 4. So if 2 power x equals 2, what's x? And if 2 power x equals 4, what's x?
2. But then swapping 2 and x doesn't change them.
No, because it's a multiplication. So it doesn't matter. Say again?
Like just say like after the quadratic part, you now say
X2 is 5.
2 raised
Yeah,
to
it's
power
fine.
x is like y.
Fine. Okay, have you got that? Continue? Yeah, okay. Let's see. Next example. Let's see what you can do with this. Okay, let's see if anyone can get this. Minus 4x power minus 7 over 6 equals minus 7x power 3 over 4. Give that a go. Yeah, okay. Got an answer? Got an answer? Has anyone got an answer?
I'm getting it moving.
I want the exact answer. Let's have a look. So look, first thing you can do is cancel the minuses. Second thing, divide. 4 over 7 equals x power 3 over 4 over x power minus 7 over 6. So that's 4 over 7 equals x power 3 over 4 minus 7 over 6. So 4 over 7 equals x power, what's that, 24? No. Yeah, 23. What is it? 23 over 12, like that? Yeah. Okay, great. What's the last step here? To get the answer. No logs. No logs. No logs. No logs necessary. No calculator. No calculator, no logs. So, you say power 12 over 23, power 12 over 23. What happens here? So you're left with x equals this. X equals 4 over 7 power 12 over 23. Quite interesting.
Very interesting.
Yeah, you could clean it up a little bit more if you like.
Hey, how did you do the division?
Hmm?
How did you do the division? 4 by 7 is equals to...
It's cross multiplied.
Okay.
What's wrong, Marwan? Okay. Can I scroll down? Yep. Okay. Next example. I want to solve where this and this meet. So how do I do that? How do I solve this? What method? Could, but something else. Equate them, yeah. So I could say 1 plus 2 e power x equals 6 minus 2 over e power x. Now, what should we do next? Could change the ex, yeah. Something else maybe? Say again? Not yet, something before that. We could, but something else before that. I should multiply everything by e power x. Yeah. So we get e power x plus 2 e power x squared equals 6 e power x minus 2. Now let me take everything to the left. 2 e power x squared minus 5 e power x plus 2 equals 0. Now what type of equation do I have? It's a quadratic again, isn't it? So now I have e power x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. That's 5. What's 25 minus 16? 9, isn't it? Plus or minus 3 over 4. So I get ex equals 8 over 4, which is 2, or 2 over 4, which is a half. Now, does anyone know how to finish this, though? So think about this. I'm saying e to what power will give me 2, and e to what power will give me a half. What do I use to figure that out? I use log, don't I? Isn't that that was the whole purpose of log earlier this morning? Log can tell me what power. So what do you type in on the calculator to get the power here? Yeah. Yeah. Which is 0.69.
Yeah.
And what's this, like 0.49 or something? Anyways, the answer will be ln 2. Oh, sorry, this is minus 0.79, isn't it? Or x equals ln a half. Oh, sorry, you should have it this over here, be easier for you to see. Okay, write that down. Yep. Yep. Plus or minus. Okay, you got that? Yeah. So the next thing to have a look at is just, if I give you something like y equals 2 plus 3 e power minus 4x, what I want to do is to figure out what are the possible values for y. I want to put, what we say, some boundaries on y. So what we do first is we imagine what would happen if I make x move towards 0. What value would I get here? No? 5. Yeah. What would happen if I move x towards infinity? What would y move towards? So e to the power of minus infinity, what's that? 0. Do you remember the graph we did for e? So this will move towards 2. And what about if x moves towards minus infinity? What would y move towards? Well, yeah. No. If x reached 0, would we reach 5? Yeah, if x was exactly 0, would we get exactly 5? Yeah, so we call this one is closed here. Could x reach infinity? No. So could y reach 2? No. So here it's open. And could x reach minus infinity? No. So could y reach infinity? No. So here it's open. So when I look at this, yeah, okay, I would say y must be bigger than 2, but it never actually is 2, and it must be smaller than infinity. And likewise, it never reaches infinity. So this is the boundary on the y. Okay, a little tricky. Write this one down. In the exam, often they just care about getting one of these. They never, well, they have never asked for both boundaries. So, a typical exam question might be, what is the smallest value of y? So, 2. Y must always be bigger than 2. So, no 2. Yeah, so you could say, what is the lower boundary of y? Anyways, it wouldn't be 3 by your logic, it'd be 2 point something. X can't equal infinity. We can make it bigger and bigger. It never is infinity. Yeah? Yeah? It's a little tricky, I know. If you want a little bit of a trick with this question, you know your calculator has a table mode.
Yes.
Yeah, you could have the calculator generate values from like minus 10 to plus 10 or something. So you could get an idea of what is happening. Do you know the table mode on the calculator?
Yeah.
Yeah? Will I show you how to use it? Let me see. Yeah, you know what I mean, table mode? Have you used it before? Let's have a look at it. Did you get any message from Rahman? Oh, just yesterday, not today. Okay. So, if I go mode, you looking guys? Come on. Hang on. Mode, table. Now, I typed this, where's it gone? 2 plus 3 e power minus 4 alpha x. Then I press equals. Oh, watch. Oh, I don't know how on that one. I only know on this one. You'll have to watch a YouTube video later. Mode 9? Okay. Right, Bello, come on. Equals. Let's start at... No, we want a negative value. We'll start at minus 20. And we'll go to 20. And we'll go up in 2s. No, insufficient memory. Okay, let's start over. Minus 20 to 20, and we'll go up in 4s. Okay. Right, now you can't quite see this, but when x is minus 20, you have a number here which is 10 to the 35.
Yeah.
Then we have 10 to the 28, 10 to 21. So clearly, as I head to minus infinity, what is my y value doing? It's heading to infinity. Yes?
Yeah.
Now, What happens as I increase it? I get 5, I get 2, I get 2, I get 2, I get 2. Okay, so as I head to infinity, what is my y heading to? 2. Now, the calculator makes it look like I get exactly 2, but I don't. It's just being rounded off. It's kind of hard. It's kind of more like this. It's kind of slowly heading towards 2. No, actually, it's quickly heading towards 2. But it's never actually at 2. This is just being rounded. So it seems like I go between 2 and infinity, which is exactly what I said here. Yeah? It's okay? Yeah? Alright, let me give you your homework one to try. So, homework, which you can start now. 1AD, 2AB, 3AC, 4A, 5A, 6, 7B. Whose is this? It's yours, but I wasn't here. Thank you. Yeah. No. I don't know how to use it. I only know how to use my one. So you can look at YouTube. Type in the name of the calculator. Casio FX. What's that? 991EX. And then type in what you want to do. Like table mode. But use headphones if you're going to listen to a video, okay? Yeah, you getting started? Did you write them down? It's only one. Yeah. You got that?